So I'd like to try a video again. It seemed to work pretty well last time, and I can pack in a lot more information in a video than I can talking live. I just have trouble focusing while I do that. So I want to discuss a little bit about this class and how sensor design, HSI, and IT I struggled to understand what was going on. So you can see here I have a little graphic which kind of says, hey, this is where I was at the start of the class. I don't know what are we supposed to do? How do I help HSI? How do they help me? Do I design a sensor and just give it to them? I don't know. So I realized, we talked about it and we said, look, we got to figure out a way to integrate. I'm not sure how to do that. So I decided to take a step back and look at it from a higher level and come up with a method that would allow me to understand at least the system that, what is this system for, as you guys know, we're managing or we're building a system to monitor the economic zone around the Galapagos. What does that look like? What does it need to have? What does the sensor need to have? What is HSI's responsibilities? What is IT's responsibilities? I don't know. We couldn't figure that out for quite a while. So I did show you already in this meeting the trade study I performed. The trade study was neat, but again, the results of the trade study were, there's a bunch of stuff here. What's salient? What do I need to look at? How do I narrow the focus? So the higher level then being, well, let's take a look at putting together some sort of study tool to help me, even at a higher level than a trade study, just kind of what is in the economic zone, how do I understand it, how big is it, how hard is it to manage that kind of area, what could be the risk factors for managing this large zone, how do you do it. Anyway, I put together a simulator. So I'm going to walk you through the simulator, and hopefully that will help. I think that'll help you understand what I was doing. Now, I did break away from designing the sensor. I just didn't design a sensor. But with the simulator, I think you'll see that not only can we design a sensor in detail, we can also design the communications and IT requirements. And what I found to be, most eye-opening to myself was how we manage the HSI portion of this. That's a huge, huge problem if we were to ever implement this kind of device or system. And I think I can walk you through why. Alright, so I started out with the idea of using STK as a user interface here. And then I wanted to use Matlab to interface with SDK and kind of control it. And I thought we could get some data from the web, bring that data in, and then run it. What's going on here? Alright, so I built this little Matlab interface here. Not rocket science, it's pretty simple, but it does the job. And let me just walk you through it real quick, and I'll try and keep this short because it could go on forever if I don't do this. So anyway, the setup here is I found this company called Marine Traffic. They offer an API service. It tracks live ASI data for any area on the Earth. You can create an area that you want to monitor, which I did around the Galapagos. It's about, in order to get that data, it's satellite-based data and terrestrial-based data. It's about $3,000 a month to use that data. But they'll, you can just ping them, and they'll send you a report of the information. So the live version is dead, the license is dead, and they wouldn't give me another version. So it's fine. I just took the data I already had and kind of turned it into a static data set. And you'll see it right here. I pull it in. There's the actual API call. It tells me it's failed, but there are 102 boats to look at. So here they all are. These are all the boats that are around the Galapagos, and you'll see the Galapagos here in a second when I tell it to build the STK model. But these, the data, it includes a special boat number, the ASI number, and then information like speed, heading, course, all that good stuff. But I also identify boats that do not have this last determination or description, which is, hey, how do we find out where this boat's at? Terrestrial boat means this was either a TER, means it's either saw visually or it was pinged by a terrestrial antenna for the AIS system. Satellite, of course, is from the satellite, and there's an NA here, which means I fudged these in right now. We don't know where it came from. I had some ideas of using some imagery from satellites and then finding a blob data on the imagery and matching it up, but I didn't get that far. But these are examples of that. So anything that's not sat goes down here into this target vessel area. The target vessel is either NA, which means it's red, which we don't have any idea what it is, or yellow, which is terrestrial. So let's go back. We can build the SDK model of all that data right here. So let me build the model. It'll plop it in over here, and I'll trim this video up with all this dead time. Alright, so it's done building the model. We have a 2D map here of the Galapagos. The blue square represents the scanned area that I'm paying for through the API service, which is, they look for boats in this area. Let me clean this up real quick. And the purple area, of course, is the exclusive economic zone for the Galapagos. So that's it. All the little dots here are boats that are in this area, and these squares are the boats that are in, recognized as suspect or target vessels. There's 2 here and 2 here, and we have 2 locations that are base stations. One here on the Galapagos. We probably won't really be able to do that in real life, and then one here on the mainland in Ecuador, and then we have 3 patrol boats that are floating around. These are all text-based inputs. You can just build a little text file. I have the text files. I'll show them here in a second. And then you just input the data, and then you can build this model with a button click. I can also go ahead and start the real-time run, and you'll see it takes off running. So simple enough, but it's pretty powerful already. I hope you can see that. And we will let me clean this up, and we'll continue with how to actually go out and reconnaissance these concerned areas. Right, so let's go through some of the basics of how this operates. And what I have here, you'll see, is a little bit of a dashboard. It's pretty limited, of course, but it tells you how many objects we have on the screen, how many potential targets we have, and if we have any UAVs that are flying. I'm not just using UAVs right now. It could be all kinds of stuff, though, aircraft, different types of aircraft. And of course you see our number of patrols, which are these boats again, and the ground facilities. You can, let's see here, what we can do is we can actually launch a UAV and then have it set up a set of waypoints, or in this case just one waypoint to a target. So let's assume we want to go see what this target is. We click it, it identifies the target right here. We can commit a reconnaissance aircraft to it. We have the opportunity to pick any one of the patrol boats or the ground locations. Let's pick Patrol 3 right here. Excuse me. And then you can pick what platform Patrol 3 has. Maybe they have 3 or 4 or 5 different platforms on the patrol boat. I don't think so, but in this case we can do that. And you can also set up a sensor. So if you got a 5-degree or 7-degree sensor, different types of. We could build this into a pretty awesome sensor development tool. So I get points for that. And you can launch the vehicle. So if I launch it, you should see. Oh, let me go ahead and restart. I had to restart because something blew up last time. So if I start the sim, yeah, now we're live. You launch an aircraft off here. What's interesting though is you can see he's pretty close, so he's already acquired the target. But let's do something. I wanted to show this because it is interesting. This is what kind of opened my eyes up a little bit. So let's pick another target, say this guy here, and we're going to go to Patrol Boat 2. We can select Patrol Boat 2. We can select this, and let's send it in there at like Mach 5 or something. I don't know. It's just hauling, what. So if I send another boat in, or another UAV in, there he goes. You see how fast he's going. So it's fun to watch this, and it looks neat. And you can see these, the sensors picked it up. It's a tracking sensor in this case, so it's tracking the target. But in real life, if we were to use this sensor as a development tool, look at what's going on over here. This guy hasn't even moved. I mean, he's barely done anything. And then this is kind of what opened my eyes to the whole HSI aspect of, this is why I went ahead and finished the simulator up to at least this point, which is, wow, this is a big deal. We have to sit here and monitor this UAV. It's active now. You can go look at it. You can go, if we were flying this, I'm assuming we're going to be able to look out the front of it as an operator and view, the eyeball view of the sensor. So this is looking at the nose of the aircraft. It's a little bit off, but good enough. This is what you'd see. We'd be flying this around. And the problem is, this is going to take, if you look at the data here, it's not going to be until 4 o'clock, 4:40, and right now it's only 3:50. So, we have to sit here an hour, 2 hours. Some of these are going to be even longer than that, 6-hour flights, 5-hour flights, if we can get there. So, this is kind of fun because now you can simulate that and have a group of people, train them. You can go through these fun, I have another tab here called scenarios. So we have all these scenarios set up. These aren't active right now, but this tool can develop, you can add wind, rain, lightning. We can drop power, we can drop communications and telemetry. We can have all kinds of malfunctions here, and then go through these in scenario-based training missions with operators. It would be pretty awesome. And then you could actually start to design sensors in this scenario and design the IT. Well, we use IT. It's kind of weird to me. It's really communications and data management here. So we could do all that live in a simulator. So it's pretty cool. Anyway, one more thing I'll talk about here, which is I can also add some dummy targets. So if I go back to the 2D graphic and zoom back, let's say we want to send one more target off from the land here, and we don't have the API working. I can go to scenarios. I can put something in here like 0 and pi, and send. I can make 5 targets. Click it in between 360 and 217 mile radius from around the center here. If I click that, you'll see these guys pop up. There's what happened? Oh, I'm using the wrong center. My center's up here, actually. Sorry. But anyway, you can see what's going on. It made a couple targets. There's a bad target. So if you go back to the front page here, targets come in randomly as either... Alright, sorry, I got cut off there. I was talking too long. I only have 5 minutes of video recording time, so I'm using freeware. But I was just going to show the last bit of this, which is the target pickup. Let's pick up this target from the ground-based system. We can select Salinas. We'll do a fast run and then kick it out. It also adds, I do a preliminary setup here, which just reads how long it's going to take to get there, and some basics of what the actual UAV is doing. I mentioned the scenarios. All this stuff is readable by text files, pretty easy. So I think that's it. I don't want to go into this anymore. I think you get the idea what I did. So now with this, the class is over. That's a bummer. I would like to go in and design some sensors now, and design some communication strategies, and then test them under various scenarios, failure modes, and all kinds of conditions, including sitting down for 6 hours and flying one of these things. That would be fun. So that's it for this video. Thanks for listening, and sorry it took so long. Appreciate it. Bye-bye.